Hey, what's up, guys? Welcome back to the channel. We're here at RRHQ, and everybody's been asking, Kyle, are you going to do a blower door on the building? And yes, we are. I've got Randy here, which you guys maybe remember Randy. He's been involved in all these blower doors that we've done. So Randy, thanks for coming down from Minnesota. We've got Jake from Minnesota. Jake is with the, what is TEC? It's
the Energy Conservatory.
Energy Conservatory. Yep. And they actually make the blower doors.
Yep.
And they've been making them since 60s?
Early 80s.
Oh, I thought he started.
First blower doors were done in the late 80s as like science experiments, and it kind of got institutionalized and modernized in the early 80s.
Okay. And then we got Chris and Nolan from Rockwell. Chris is like the man that's been down. He's done installs with us. And Nolan is like the territory guy. So I'm in your territory. So we've got a blower door to set up, and stick around. We'll give you the score at RRHQ, and hopefully also show some of the details that we got to work on still, because no one's perfect and the goal is to get better. So let's get into it.
So you need a building pressure on windy days. If you can somehow get to the leeward side of the building, that's the most stable. When wind hits a building, it affects the leaks. It's most variable on the windward side. It's calmest on the leeward side. This looks fine. Like there's no breeze. So it matters very little on a day
So you
like
said
this.
put it on the less breezy side.
Yeah,
Makes
out of
sense.
the wind. Yeah.
I think we had that problem on the last one. It was windy as heck outside. Remember how windy it was? It was, yeah, Remmers was really windy.
If you need to, you can actually, in that case, there's couplers. You have enough hose, you can actually drag the hose around to the other side.
Yeah.
Okay. Doesn't change anything. I mean, kind of like water pressure on a long hose
Up
changes,
to
but
100 feet. Is that what the length is?
And if it goes through like hot and then cold, that can mess it up a little bit. We have this little. I mean, it's 3/4 inch. Just PEX line, but we usually hook this on the end of the hose that goes outside. If there's any moisture outside, it keeps any moisture from getting into the tube, and it gives it enough weight. So we usually connect this to the end and then just set it along the lower edge of the building. So probably
how does it keep the moisture out?
I'm just saying, if there were, the inner diameter of these is so small, anything that gets in there and partially blocks it really messes with the pressures.
Okay.
So this basically gives it a little break.
I gotcha.
Water can't get in there, creatures don't get in there. I actually have a guy who had something crawl in there. Rare, but hook this to the end of the hose that goes outside and just set it at the base of the building up against the wall.
Okay.
That's, there've been a bunch of research about where to get an outside reference that isn't super useful to the common person, other than just low and next to the building and off
that's
the
a new one.
side.
Yeah.
So, yeah.
We're learning.
Get it back into that same spot.
Yeah. Then throw your cams.
Yep. And make sure you're all the way back against the jam. And then you've got a bar that you put in afterwards that the fan hangs from.
Gotcha.
So that one goes.
Is that a certain exact height? Is there? Because I see there's other lines, but you just go to the bottom one.
Go to the bottom one.
Okay.
For big buildings, people will add a second fan, and if the doors are high enough, a third fan for really, really big buildings. So yeah, you've got all these, so that as you stretch it out,
Okay.
You
So you sell a different
panel.
red door that has another. Okay.
Yeah. I mean, entire apartment complexes, high rises, they'll do this test for. So.
I guess I didn't realize it took more fans. I just figured it still measured the same way.
You're limited by the CFM. So that's about 6,000 CFM is all that you can push through there.
Oh. So if you need more CFM, you need another one.
Yep. So this just goes around. There's a groove cut out right there.
Yep.
So this pops through and should stay snug right around that. That's the fan, that's the door, and then this is power supply.
There you go.
Okay.
Thank you, sir.
I didn't see you pull the green hose back through the hole, but now it's there, yep.
Yeah, I just set it out first, put the frame in, and then you pop it through.
Yep.
Right there. And then there's a hanger bar that you hang on here, and then this will just mount the gauge.
In one of those slots.
On the side of the door frame. There's a good spot. So.
Magnetic?
Yep.
Nice.
Gauge pops on there. Tubing assistant will step you through how to get it set up, and it'll do most of the setup for you.
Okay.
So People will test ductwork, air handler flows, bunch of other stuff, but you're going to do building tightness. And then you're going to tell it, are you pressurizing or depressurize the building?
Which we're pressurizing?
In this case, I'm going to depressurize just to start. So the rings are on the inlet side of the fan. So in this case, just to do a quick check, we'll depressurize it. And then it's going to act as the gauge inside the building. Sometimes you have access. Sometimes you're doing row houses or something and you're outside and you're testing from the other direction. So gauge is inside the building, and you're always going to select the first fan. That's the duct blaster fan. Randy's got one of those.
Oh, okay.
These are European fans.
All right.
So you pick that one. It'll say, hey, is this building tightness, depressurization? Yep. Hit continue. So it'll say, there you go. That's how you set it up.
The crazy thing is, dude, I feel like I'm such a Neanderthal when it comes to building science when I'm with Randy and stuff. But then I'll talk to people in the market around here, and they're like, what's a blower door? Yeah, and they're like, I have no idea what you're even talking about. So the market might have blown up and changed, but it's only going to get better, for you guys, I would think. I mean, or guys like Randy who nobody wants to buy this or learn. They're like, just pay you to do it, you know?
Right. Yeah, I mean, what Gary was saying when, to me when he came out, with his first blower door is that he thought it was mostly a tool for builders. He was like, we get this in the hand of builders, give them 5-10 years, and we're gonna, he's like, by the late 80s, we'll have this whole thing figured out. And
it's 2025.
It's 2025. Almost. But this is the perfect time to do it.
Yeah.
We're not finished yet. We can still make changes. And a quick spot check of where we're at and what do we need to do to get to where we want to be. Gary Nelson founded the Energy Conservatory. He didn't invent the blower door, but it was kind of a lab tool. In the late 60s, 70s, people were figuring out that buildings leaked. But if you look at some of the first research, they didn't know how they leaked. They assumed that it was the windows. The first tests found that the windows didn't leak nearly as much as they thought. And they didn't realize that it was inside of walls, unintended cavities, plumbing chases, electrical, and it opened a lot of people's eyes. So Gary got interested in that. He made his own. Had someone else ask him, hey, can you make me a blower door? He was like, oh, sure. He made him a blower door, and he kind of just, he says he kind of backed into it. So he started making them so that they were portable. The original ones were a lab setup. I mean, it was a 10-foot piece of straight duct, and it was not something that was portable. You couldn't move it around.
That's interesting.
So, yeah. So now we can get it into a door, get it set up in a few minutes, get your test done.
Yeah.
So.
And obviously the reason for this test at this point is the fact that we still can find the leaky spots. If you guys remember, Greg and I found when Randy was out last time, what did we blow? Like a 1?
Yeah, I was like,
and it was like, oh, not bad. You got a 1. It's like, oh, that's not great. I want better. And we found a 10-foot section of our Myrex that was not even taped. And we do good detailed work, and we forgot it. And we've been staring and doing work in here forever, but this will tell us, hey, you guys forgot this or that. Or you need to maybe look a little bit more into that girder truss that we know is going to be an issue. So now is better than when the drywall's up, when the finishes are done, and then you don't have access. And you can just say, well, this is our score. This is all we're going to get unless we get an aero barrier or something in. So, this is great.
So you got that set up. Hit the play button here. And then you can have the gauge display just the raw CFM. You can have it show you the ACH 50. If you're going to do ACH 50, you have to tell it what the volume of the building is. So then we'll just do raw CFM. You can always come back in and plug it.
We're just going to do that anyway, right? So we can kind of find some leaky spots and then maybe do the actual test.
So I'm going to guess.
You'll know based on CFM how decent it is, right?
Yeah, I'm guessing B-ring, right? Okay. That's so each one of these rings then is essentially kind of like a gear. So if you have a really, really leaky building, you take them all off. You need the full capacity of the fan. Each one gets smaller and smaller. So for the type of building this is, I'm guessing ring B.
I'm guessing C.
You're guessing C?
Yeah.
Okay, so he's.
I'm hoping D.
Okay, hoping ring D. Okay.
Yeah.
So channel A tells you your pressure. I'm just going to do a quick manual check here. So I'm just turning this up. We're going to depressurize the building until it gets to roughly -50, just to give us an idea of where we're at. Flow is displayed over here. So really rough check if you're in process. So you see that I stopped turning the knob.
And it kept going?
It kept going.
That's a good thing,
that's
right?
That's a sign of a very tight building. It's a tight building with a large volume and a very small leak. All right. So just a ballpark number to start. We're right around 50 there. 550. Okay, we need the volume to know that same leakage on a really small volume could be a really bad score. This is a pretty big volume. I think you're going to be good, but let's calculate volume and we'll punch that in there for our final test. So with this going, we're now pulling air from the outside through all the leaks into the house. So if you have infrared camera, this is using this and just leaving this like this.
Yep.
Let it go for 5-10 minutes. You're going to start to, in the winter, in this climate,
See the cold spots.
air in. You could look with an infrared camera and start to see the shape of a cold spot on the wall start to change, indicating that you've got an air leak in there. So that's one technique you can use with the blower door. The other one is walking around with smoke. So if there's a leak, the same pathway of air coming from the attic or the outside into the house, induced by this blower here, we can use smoke to then walk around and actually pinpoint where the leaks are. I'm going to flip this around.
Okay.
And I'm going to push air in, and we're going to be able to see air get pushed from our side through the leak.
It'll get sucked right through any crack.
Right. So
Okay.
I just want to do this to get you a rough number quick while the
Okay.
rings are on the inside with me. So every time you're in a house that's got anything natural gas, yeah, you shut them all off.
Okay.
So just the pilot light for a water heater, or set a thermostat to just, off. Just making sure it's not coming on. Same
Okay.
thing with a boiler, heater doesn't really matter, furnace doesn't matter. Electric heat, obviously there's no combustion, you don't have to worry
Yep.
about that. So safest thing to do is just shut those off when you're doing the test, because this is far stronger than the natural draft in a building.
Okay.
So we've got the fan flipped around. It's pulling air from outside through our leaks, we're pressurizing, we're pushing air into the building through our leaks. So we've got this cruising, so it'll just maintain that pressure. We can just walk around and check.
Okay.
So what details? You said this girder truss?
Well, we know upstairs that girder truss is probably going to be an issue. I mean, we have monster garage doors, right? Will we start to see that just suck then to any gaps?
Yeah.
That's what we would expect to see, like down here in a corner.
Seeing that swirl?
Yep.
If we had the fan the other way pulling air in, that swirl could have been a leak. When you're pushing air this way, you can see it get drawn into.
That makes sense.
So getting a focused amount of smoke near something that you're looking for helps you identify it.
That makes sense. Yeah.
Yeah, there's air moving around in here as well. So is
Maybe up at the top or something.
a ladder would be nice.
Well, let me tell you, I got a ladder right here. Oops. I got a cobweb right here. It ain't moving.
Yeah, cobwebs are a good.
Oh, see, there it is. Right there.
Yeah.
See that that seal is open and it's pinched.
Right.
That should have been cut down so I can literally put my finger right here.
Right.
See?
There.
Yep, and I'm assuming it's going to be the same over on that side. Yeah. Huh. I'm not going to worry about cutting that just quite yet.
Yeah, and your seal in here looks like this seal.
Mm-hmm.
It's good. It's just moving in between, this
Yep,
space here.
Yep. I mean, up there was plain as day. You could see it just go
Yeah.
suck right out.
Yeah.
Yeah. I knew that was probably going to be a spot because I can see some daylight,
Yeah.
So daylight's not good when you're
Daylight.
inside. But
You want to check these?
yeah, let's check these over here. I mean,
So it's both.
well, we've got the vent stacks.
These? Yeah, those look really good.
And we got this this guy down here. No,
Yeah.
there's nothing there.
Yeah.
I got one walk door over here. We could walk over, but I want to see what's up with this girder truss. Yeah.
Let's go take
That's
a look.
kind of where, since the beginning, I've known that the girder truss, Greg and I totally messed up and we didn't air seal that detail properly. We'd never done that detail before. And I guess we're gonna find out just how much it mattered. My concern is like specifically, yeah, come right down here. So this is a ply that basically goes up to the attic. See?
Right there.
Right there, see that? Yeah. Because there's the air control layer stops on the top side and is not encapsulated. Every ply, unless it has a gasket seal between the plies, you have to chase that leak entirely through this whole thing, every ply.
How do you get?
Yeah.
Right.
My whole thought was, I could have done like a full, I could have filled this all the way up with closed cell, right? But then down here, yeah, the only real way would have been if I would have encapsulated this girder inside the air control layer, but we didn't think about it until it was almost too late. So the real question is like, what are we actually losing in CFM? Like, how much are we actually losing from just this? And how would you know?
There's a test you can do for it, but it's called add a hole. We have to make a hole to get up into that fairly good one. We have to measure pressures before and after. So there's ways to figure it out. It's an estimate. It's not perfect, but it's close.
Yeah. Well, I think what I was saying is how much really will this affect performance of the building, and how much effort should you put into trying to rectify a little tiny leak? Like, what does that really equate to,
In a leaky house, it can be a bigger deal.
Yeah.
You're starting with a pretty low number already at 500 CFM. So no matter what, you're gonna be chasing small leaks.
Yeah.
So the impacts are
Minuscule.
often less. If there was really high moisture in here and it was getting driven in there, maybe that could become an issue.
Yeah.
I think the scale that you build to, my hunch is that if you could do some manual sealing here before you encapsulate it and seal this all off, I think that'll probably be enough.
Same detail, but the difference here is this top detail is just in the attic.
Yep.
This is actually at least up against an air control barrier, the Weather Logic on the outside. So I'd have to kind of make my way. I don't know that it's probably an issue. I mean, this is where I was kind of worried, and I don't see.
Right.
It's not sucking out. Now maybe this side, I don't know. It's mainly. Yeah.
Yeah, and you're getting the
Oh,
same.
I saw that.
the
Yep.
same-
Little tiny spot right there. It's because this ply is opened up. I mean, you can.
Yeah.
Yeah.
I've seen people use mastic, like a duck mastic, and actually get in there and get a good seal, and that stuff's pliable and moves. So that's another possibility too.
Yeah, I was just going to use big stretch. It's kind of always. Oh, the other thing was I thought, if I really want to, when we see these numbers, I can always have aero barrier come in too.
Right.
This is like where I messed up as a builder, and I didn't think all the way through the air control details.
Yep.
Well, how much time do I want to spend,
Yep.
or how much does it cost to get aero barrier in here and spend an hour?
Yep.
And then it's done.
Yeah.
Or I take it to whatever number I want it.
Yeah, and you're at the point too
I
where
just feel like that's cheating.
well, there's not. Air barrier can't get over a certain size gap. I don't think you have any of those scenarios in this house. You're down to a really good application of it, I think. So,
Cool.
So what we have is we're pressurized. We're pressurizing, right? So we're pressurized inside the building to 50 pascals. So when we take a reference to the outside, that's 0 volt there compared to inside. When we're up into an attic space, now we are basically outside. The attic, we're pressurized. This is 0. So we're pressurized to 50 pascals in here. Now we're outside the building.
Yeah.
With reference to inside, which is telling us we got almost a perfect air barrier here.
Okay.
If we were reading, let's say 25,
Yeah.
that would mean that the holes inside the attic or the conditioned space equal the holes in the roof. You've got some air leakage. If it read 0, that means you have no air barrier. The ceiling air barrier.
Well, there's Weather Logic on the entire building.
But that's a vented space, right?
It is vented,
So
yes.
it's connected to the outside.
Yep.
Yeah. This is the hardest thing to get your head wrapped around is these pressures.
So,
This is good.
okay. I was trying to make sure I understood that, because to me that meant that my air. I thought you were saying that my attic wasn't venting then.
Nope, with a vented attic and
You want to be as close to this number here? That's the goal?
the 50 pascals, yes.
Okay.
Yeah, so it's if we were at 45, you would have some connections inside, and maybe we'd be looking for.
Okay.
I'm saying it's almost perfect. So these little leaks that we're detecting through here,
Nominal?
we're not accounting to hardly anything.
Okay.
If we're hitting the goal, so let's say your goal was 1,
Yeah.
and we're at 0.8, as long as we don't have any big holes, I'm good.
Because it should get a little better with drywall.
It should.
I mean, it should. I mean, in theory.
Yeah. Yeah.
And code in most places is 3 air changes.
Yeah.
Right.
And when we do a multi-point test using software, the software can actually estimate the size of the cumulative holes based on either 4 or 10 pascals of pressure.
Which is more common, like what you would expect to see in a normal scenario.
Yeah.
Like you were saying, we don't see 50 pascals of pressure on our buildings constantly, ever. You know, that's like it's a constant wind.
20-mile-an-hour wind.
Right.
Okay.
So a 4 pascal or 10 pascal is more of kind of a natural ventilation rate, depending on
Makes sense.
what season you're in.
I don't understand why guys are doing 3s and 4s. That's what I'm saying. Is
Not that hard to get to.
no,
Pay
I mean, yeah, that's what kind of blows my mind, and that's where I guess I thought it's like it's not hard to get down here, but then to keep going, it gets like just not worth it.
I think the other thing when I compared to buildings that you know, other buildings and the way you build is the shape of your buildings, and well, A, your attention to detail, but B, the shape helps a lot.
Yeah.
So these are shapes that make it easier for you to get a good air barrier.
Yeah.
Bump outs, cantilevers, different roof heights, change in ceiling heights, all those look great and people like them for a lot of reasons. They make air barriers really difficult. And
Yeah.
so you guys are knocking this out of the park
Yeah.
with this design. So
Yeah. Huh. Well, that's what I always try to tell people is like, dude, if you want a barn dough, don't try to put all these other weird roof lines and like little breakfast nook bump outs and things. Like now you're just going away from the whole reason that this is such a good design is because you're taking away the efficiencies, you know?
it's you're getting really good control. You're also not introducing a lot of leak or penetrations to the outside, like minimal, right? I think you said you have probably 3.
3, yeah. Everything else comes in through the concrete underneath in a sleeve and,
Right.
you know, so yeah.
Versus let's have a whole bunch of things go through the attic where, you know, as heat rises in the winter, the pressures are the greatest up at the top of the building. That's a horrible spot to poke in 15 can lights,
Interesting.
you know?
Yeah.
And you're not doing that.
Nope.
Your top is nice and solid. So we're looking at small details where things intersect, which is the next spot for big leaks, but you're designing out a whole bunch of leaks right from the get-go.
Interesting. Didn't think about that.
So just in this corner here, but this is the nature of double hungs.
Yeah.
You know,
I did it for the look and
it's
for
like here it's fine. It's kind of, you know, getting pushed back in.
Yeah.
Over here.
Yeah, and there's
Same
nothing
thing.
you can do about that.
No. So these are things you can't change.
Yeah.
That, as long as your drywall's off, yeah.
But it's a good thing to mention. I mean, because people, when they design their home, if you're looking for energy efficiency, don't put double hungs. I mean,
help it.
if you can help it, you know, you can get a casement that looks like a good double hung from the outside. But yeah, I knew that was probably going to happen, you know.
Is it the end of the world? No.
No.
But there's some imperfections kind of built
Yeah.
into these. So
Well, you got to find something, you know, we got to have something to work towards, you know. I mean, there's literally nothing, dude.
yeah.
Oh, that one does. Little tiny right there. See that? Right on the... And I can see that, really.
It's out at the end.
Yeah, the very corner, probably.
Yeah.
I could open it up and probably see that the seal is... See, it's not there. Okay.
There you go. Perfect.
There you go. I'm already on it.
More behind it, except for
I'd hit those too. As long as you're here, there's a little bit of
Yep.
leakage coming in between those. Wow.
Once again, probably very minimal, though, right?
Yeah, it's not a lot, but it's definitely drawing smoke in.
But it won't hurt nothing to take a...
No, again, would I rip if this is finished? No.
Yeah.
But as long as it's open, the
Doesn't
effort's
hurt.
so little.
Yeah.
To get it. So. Okay. Yeah. This is impressive, though.
Okay, cool. I like to hear that.
Yeah, and I mean one detail, right? And you said
I knew that was going to be the one.
Changed from your typical design.
Yeah, never done this girder truss design, so we hadn't really thought through it until we started doing this floor system. And we thought enough to at least run all of our air control layer behind it before we put it in.
Right.
And then we're like, oh crap, what are we gonna do here? And I talked to Randy about it. I asked him what he thought, and it was kind of like we came to the determination that do your best.
Yeah.
And if there's one little spot, you know, we could aero barrier if we didn't like the numbers.
Yep.
But how far do you chase it? I'd rather wait, see what the scores are, and say, okay, you know, how much is it worth?
Yeah.
How much time, how much energy, how much material, all that stuff to chase point whatever we want, you know. So that's what we'll find out is where we at, and you know, obviously this is big volume, so Randy will have to do his volume and then also his surface area, which how do you do that in here with all these different ceilings and everything?
Spend some time.
Okay, good, all right. As long as you got an answer.
Yeah. I think in this, if that's where most of your leaks are,
Yeah.
I mean, we got 42 feet by 3 or 4 in height, you know, to go over by hand. I think you're within striking distance of just doing this by hand.
Yeah. It's good enough for me. Yeah.
Yeah, I think with this design, there's not a lot to check.
Yeah.
I mean, your walls, great. You got continuous, you know, ceiling.
That's good and bad, Jake, because if there's not much to check and you don't like your score, what do? You know? Yeah.
Right. Let's do that.
Let's cover up Randy's hole real quick. Oh, all righty. No worries. Send me a bill. Oh, Greg did it? Okay, I did remember that you can see this vent pipe right here. This comes from my floor drain. And my Sega Fentrum, it's this tape right here, is how we air seal from the Myrex to the concrete. But I've got a gap of about 1/2 of an inch where that pipe is. And look at this. That's a pretty big hole. So I'll probably, maybe we'll leave it. We'll run the score. We'll get the volume figured out, and then we'll put a piece of tape over it and see really what that equates as far as the blower door score. So I'm just going to give you the sections because it's easier. This is 24 by 45. This is 32 by 45 by 16. And then this is 24 by 45. And this is a little bit different because we have the angled ceiling. 2.72, right? Yeah, 2 3/4.
3,600 square feet, does that sound right?
Upstairs?
No, total.
Well, that's floor square footage.
Floor square footage.
Yes, yep. Yep, 18.6 over there, and then that's 18.6 plus the added height, which is...
The pitch of the roof?
Yeah, the pitch of the roof is 2.72, 12 feet run. I mean...
We don't have to get that close.
Yeah. That's the full height, which means if you took this number, if you laid that triangle over, that's close enough.
14, 16.
It's actually more because the other side's not pitched. The other side's flat. Does that make sense?
Yeah.
Okay, good. Okay, good.
Well, and you've got 8-foot pitches on 2 of them.
Let's figure that out. And if we really wanted to get particular, you're going to subtract 130 square feet out of that measurement to take care of the angled 8 feet on each side.
Okay, got it.
I mean, just ballparking it.
Yeah.
It's just ballparking.
That's a lot of volume. This is more than what I thought. It's 19. So we got a volume of 65,038. What did you say our score was?
You can plug it on the gauge too, and it'll read live.
Okay. So 65,038.
65,038.
Bum, bum.
Showing our flow at 50.
Yeah.
So you can go to this gear button here, and you can go to the volume.
Now we could have done this at the setup, right?
Yep.
So before we type that in, we're going to take guesses. You know, Randy, you've done this enough to know about what we're going to be probably.
Under 0.5.
Okay. I mean,
sure.
I was thinking 0.5.
you're such a. I think we did this already, didn't we? And you already gave a number.
No.
Okay, I'm gonna say it's under 0.5. So I'll do the over under.
Okay.
So I'll do 0.1, right? Then I win. Price is Right rules.
Okay.
I think. Yeah. Right.
And now you can ask it to display You have a bunch of different options. ACH 50. And there's a description of it. It goes right there.
Wait a second. Did you just did the math? He told you to do the math. You little liar.
I guess.
So this is, I would still call this a rough one.
Okay.
I didn't baseline the gauge. So wind hitting the building would affect it. Since we were just diagnosing, I was just cranking up to 50. So you can see the wind is pushing us around a little bit. So baselining it helps. Also, when you do a test for code, they want you to enter the altitude you're at.
Oh.
If we're doing this in Denver versus in New York,
Because they're so much thinner.
right, you're going to get differences. Which, I mean, buildings don't move, but you know where you're doing the building, you should put in the altitude. So, and the inside and outside temperature.
Oh.
So the density of air actually matters. So the inside to outside temperature can have a few percentage points, up to even like I think 10 or 11% impact if it's in our climate. You know, when it's like a 70-degree difference between inside and outside, it can have a big impact.
And we might be only 20 degrees today, right? I mean,
so
that makes a difference.
I'm just saying this could move. It will probably move a little bit when you do the final test, when you baseline, and when you temperature and altitude correct. So, but for a spot check, yeah, you're going to be in this ballpark.
Okay, so in theory, we could close up that hole over there.
Yep.
That seems like a decent sized hole based on everything else.
Yep.
And see how much it changes in real time. We knew that this was a potential air leak spot. Let's go ahead. Let's see, how do I do this? I'm gonna go here. But I can literally hear the wind just blowing through this door because this has not been, it hasn't been air sealed yet. I mean, we put the doors in different than the windows. The windows got seal taped with Razan or the Fentrum IS-20, and the doors didn't. So I was going to spray foam them and then do my air sealing later, which I haven't done this door yet. So I know that it's leaking. You can hear it.
Yep.
It's pretty loud.
If you get a tight joint too, like some of those, you could do the back around caulk, and that's what I've switched to on mine.
Instead of spray foam?
The thing I don't like about spray foam is that you can't tell how far back in you're getting.
Yeah.
And there's a drainage plane back there, right?
Yeah.
So if something is running bad, you got something leaking in there, we don't want to get hung up on the spray foam. We want it to run.
That's a good point.
Through.
Yeah, I don't like using the spray foam. It's just how else do you do a really good job? I can feel the air just.
You think that? How much do you think that would drop the score? Like
It's not a lot, but a little bit.
Yeah.
You're 0.05 maybe.
It's like Jake said. Like we're not looking for big holes anymore. We're looking for the biggest hole, which this is, and then right back here. But I don't, that's not. I don't think that's nearly as big as this. I mean.
Yeah, that's the entire perimeter of the door, really. Yeah.
Listen to it.
Yeah, you hear it just sucking air. You can feel it.
Yeah.
The nicest thing is you know it's there. It's the ones that you can't find.
Yeah. Not that I think I would have ended up doing anything before I did that. Like I knew that I didn't have that done, but oh yeah, that's just like, I just can't tell. You don't have your blower on you, do you? I feel like it's, oh yeah, there we go. That's stopping a lot of it. I guess you could go look at the number and see, okay, if I close it, is that going to change anything? Right? I mean, you'd be able to see the CFM right now, right? Hey, Jake.
Yeah.
Are you by the fan?
Yeah.
What is the CFM right now?
608.
And what about when I do that? Did that change it at all?
Yeah, hold on, it's settling down. Wow, 550.
50 CFM.
That was a lot.
That's 10% almost. Yeah. That's the door getting sucked open and the latch is not tight enough.
Yeah, that dropped all the way as low as like 545. So that was 60 plus CFM.
Mm.
So I'll just show you really quick how to do the baseline.
Yeah.
So when you're doing a check, put the lid on so that we're sealing it off. It's not relieving in the pressure of the house. And then you've got a set baseline button right here.
Okay.
So you hit set baseline. This turns into a timer, and this is measuring the baseline pressure. This baseline meaning this is the effect, stack effect in the building and wind. So this is all kind of the natural pressures.
Okay.
The reason this matters is we're all agreeing to test at a certain pressure. And if you tested at a lower pressure, you'd get a lower number. If you tested that same building at a higher pressure, you'd get a higher number because you're just pushing
Makes sense.
harder or less hard on the leaks. The wind is also affecting the building constantly, pulling and pushing on the leaks. You want to at least account for it. This is less than a Pascal of average wind pressure over 37 seconds. That's almost nothing. On a windy day, when the trees are moving, you'll see this thing bouncing all over the place.
Okay.
So this isn't going to have as big of an effect today,
Yep.
but it can. So you go about 30 seconds on a windy day, hit enter there, and now it'll say baseline was -1 pascals during that. So now we've deleted that out, and the gauge is now staying really close to zero. We're essentially kind of zeroed it out for this situation. So go ahead and start the fan up with the lid off. And because you have such a tight building, you'll see this kind of overshoot where it's getting everything equalized. So it's kind of dialing back in. It'll get it close to 50 and we'll still see this dropping. So we were at 606. So yeah, that hole sealed up, those gaskets. Yeah. About 50 CFM less. So that's about
8%.
Yeah. So now we can go, and since we put in the volume earlier,
Yeah.
we can hit that and go to ACH 50, hit the back button, and yeah, we've dropped
So 10 point, what would that measurement be?
I mean, we were at 0.5354 before, so,
Yeah.
you know, so a few hundredths.
A few hundredths.
Yeah, with, you know, sealing up 2 of those
Yeah.
leaks.
Very minimal effort. I mean,
Right.
might as well do it if you can find the spots.
Right.
Yeah.
So if you hit the top of that
Garage
door
door
again, so that's
another-
sealing well. You'll
Another
get a little bit more
hundreds,
off that.
couple hundreds.
And then, yeah, spend 60 minutes with
Yeah.
somebody going and hand sealing some of those leaks. You could do a spot check with this while you're doing it to see what the total leakage is. I bet you could see this below 0.5, you know, with not much effort.
I mean, I'm not disappointed with 0.5.
Yeah.
I mean, it's a shop. It's got 2 big garage doors. It's, you know, I'm happy with that. But obviously, you know, it's nice because you can feel like you do a good job, and they call it the red blower door of truth for a reason. Like,
Yeah.
you know, you're going to know where your leaks are,
Yeah.
or at least that you have leaks, and you still have a room to improve and find new places to do better air sealing, you know?
Yeah.
I mean, I like it.
For you, it seems like a quality control thing.
Yeah.
Like, hey, I know this design really well. I changed this one thing. Let's check it.
Yeah.
How's that design changing? You know.
Yeah.
I've got a new HVAC guy trying a new system where he's going to punch extra holes. Did
Yeah.
he actually get them? You know,
Yeah.
stuff like that.
Yeah.
So, but
Cool.
yeah, there you go.
Heck yeah.
Really nice tight building again, man.
That's awesome. I mean, what's the exact passive number? What is that?
Changes state to state, but it's typically 3. So you're
Yeah.
6
What
times.
was it?
That's 6 times higher than this. You know,
3?
a 3.
Oh, I thought that was just code. I mean, is it passive?
That's the code. Yep.
Okay.
That's in most
What's it do there?
Randy connected to my gauge
Oh,
remotely and shut it off, so you can control the gauge with the phone.
awesome,
Randy
awesome.
just showed us that.
My phone will connect to it. Your phone will connect to it as long as you have this app.
Yep.
Just Bluetooth.
Yeah.
Yep.
That's awesome. Overall, it's another example of, I guess, an efficient design, really. I
Yeah.
mean, it's a great way to build a home
Yeah.
if you don't care about 400 roof angles.
Right. The concerns you have with hitting this number, like I said, you're doing this almost just your attention to detail in your design.
So here's another thing I was thinking about. We talked
That's
about.
not normal. Most people are fighting,
Yeah.
to get to those numbers until they adjust their building practices, and then it becomes pretty easy. But if you're coming to this for the first time and you've never done it, it's a bit of an eye opener because you're expecting, hey, I don't see any holes anywhere. It's all those little things that we're finding. These little tiny holes do add up quite a bit over an entire building.
Yeah. The other thing that I wanted to note that I think is important is that this air barrier with tape has been sitting here for almost a year.
Oh, wow.
So it's I think there is a difference after seeing it. I mean, there are spots that we had to go through and detail because of where maybe it's pulled apart due to pressure.
Yeah.
I mean, every other one we've always done has been pretty recent to the actual work being done versus it's been sitting here for almost a year, but I think that's a good thing because it has performed over the course of this year. The tape hasn't given away. People that are worried about a tape seal or whatever,
Right.
I mean, we're still pretty darn airtight even after all this time of just sitting there.
Right. And have you been heating it the whole time?
The heat came on like 3 weeks ago.
Okay. So you had times where this was ambient temperature, so it saw some temperature swings.
Oh, for sure.
Right?
It was 100 degrees in here because I didn't have anything, but I didn't want it open to the world. So it'd be 90 degrees in here and humid.
Right.
And I tried, kind of letting it do its thing. So it's moved around.
You've cycled it through some seasons.
I've adjusted this door 3 times. I'll put it that way.
Yeah.
because it's moved around.
Right.
Yeah.
So if it's made it this far and it's going to be under more controlled situation after this, you got to expect performance is going to maintain.
I'm happy, dude.
Yeah.
I know what it's taken to heat over there, and it's super efficient. I mean, I knew the garage doors would be a little bit of an issue, but they don't seem to be that big of a deal, actually. Yeah,
Equivalent
17 square inches.
Yep.
So the leakage on the building is equivalent to 17 square inches, which is 4 by 4.5 by 4.5.
Yeah.
Yeah, that's hard to chase that kind of leakage, man.
Especially when you're talking it in 30 seconds.
Yeah.
I
mean, if you added up the linear footage of all those girder cracks,
right.
that's hard to but also easy.
Equivalent leakage area is just a good visualization tool.
Yeah.
What am I really chasing here? And you've got
two business cards side by
Yeah.
side.
Yeah.
And then that's how big your
Yeah,
variables are.
interesting. Yeah,
And
it's
if
kind of hard to really be motivated to chase that, to be honest.
at your results, you're good.
Definitely I'll do the easy ones. I mean, but, after that, it's kind of like, if there's a tiny gap somewhere in a corner of a window, it is what it is. That's the window. What are you going to do?
Yeah. You are at the level of high performance.
Yeah, this is good enough.
You're there.
Yeah.
You're there.
Cool, man. Well, that was awesome, dude.
Yeah.
I mean, that's been a year in the making, I mean, Chris was here about a year ago when we were doing freezing install of insulation, and people have been asking since then, I can't wait to see what the blower door is. Well, 0.52.
Yep.
Good enough for the girls I run with, Awesome. Jake, dude, I
Thanks,
love
man.
all the information.
Yeah.
I mean, I'm a builder, but I'm a geek at heart, and I like to just learn, and Randy, you're always got a ton of good info, man.
Yeah.
This is great. And the best part is that you, this week, were having issues with girder trusses in your business and trying to figure out solutions and everything. And what did you find out?
The easiest fix is to get that a sill seal on that top cord as you're assembling the multiple trusses together.
Yeah.
I mean, sealants will work, but think about taking a couple of those trusses that might weigh a couple 100 pounds and trying to put a sealant.
That's 4,000 pounds that truss weighs.
Ooh,
So you're not moving it around.
no.
Yeah.
Yeah. So
Yeah.
It's going in once.
Cool. Awesome, guys. Well, now the good thing is we're going to be able to do these tests and do them in stages. So it's not just going to be, hey guys, let's do one at the end of the job. We got a house coming up. We're going to be able to do it at air seal. We're going to be able to do it at finishes.
Yep.
If we leave for a week or two and a mechanical guy comes in and it's like, what did you do here? We can run a test and see if he messed up any of our air barrier.
Yep.
Because that happens. Guys will rip holes in the Myrex and they don't think nothing of it.
No.
And then it's like, well, yeah, that's a big deal. So this is awesome. I love learning about science and how to be better, how to do better, because anybody can think you're good, but when this thing goes up and it starts doing its thing, you're going to find out really, where you're at.
Yeah.
And then you can challenge yourself because Jake brought an E here, which I don't know, explain that. I mean, that's basically a big challenge for us.
If you ever have to use an optional, ring C, you're a good builder. You're doing a great job. If you get to use a D or an E, you're knocking it out of the park.
Yeah.
And you're right there.
Well, we're going to. I like challenges, man. And we've got a house coming up that we will blower door. And we're gonna at least move into D.
right.
At least D, but you never know.
Okay.
It's a simple design and it's built for high efficiency. So
Awesome.
I love it, dude.
Yep, great stuff, man.
Heck yeah, I appreciate it. Thanks. Hope you guys enjoyed this as much as I did, getting the information, kind of getting understanding of how high performance even a garage can be, because who cares if it's a garage or if it's a home? I mean, do good work, do good detailed work, and you're gonna save money in the long run. You're gonna be more comfortable, and that's really what it's about as a builder, is just to build the best possible thing and then back it up with test results. So we'll catch you guys on another video. Make sure you hit that subscribe button and hit that thumbs up if you enjoyed this, and follow along for more, because now we're gonna be able to do more tests.
So this is designed to work in a duct system, but you build such tight houses that we can actually test your buildings with a smaller fan. Exact same principle. You know, you've got rings that fit on the outside of the fan. The tubing setup is the same. You basically just need to update the gauge and say, yeah, I'm using the duct blaster fan actually for this. And you can go to your CFM, and we're gonna do CFM at 25 or at 50.
And so is the advantage to this, if a guy only builds high efficient homes, that he's like, I don't need this big fan because it saves money to get the little fan?
Yep.
Okay.
Yep, it's lighter. Folks that do multiple tests in a day, or if you're using like apartments, it's really popular in apartment buildings, where if you have to test a whole bunch of units, you can just move this thing super
That makes
easy.
sense.
But yeah, I mean, for the type of houses you build, this would be almost, I think, overkill in some of your houses.
Wow.
So it's, but yeah, we got that set up there, and in a very similar way, we can set a baseline, but just for demonstration purposes. So it's same thing. Turn up this
Chase it
channel.
to 50. Does sound like a jet turbine there.
So in this case, I've got this turned up all the way. We're at 30. So I'm in a scenario where I've selected a ring that's too small. It's too choked off for this. So if you're running the app, it would say, hey, let's switch to the next ring.
Yeah.
So in this case, you put this on, and then this band holds it in place.
Okay.
And then with that in place, then you just update your gauge here to ring 1, and then hit back. And we can do the same thing. You could manually turn it up, or you can have the fan, the gauge do it itself. Either option works. So, and again, since you have such a tight building, I stopped adjusting the fan and it's still equalizing. So I stopped turning it when I got to 50. It continued to build pressure.
Well, we know it's going to be right around that 550, 560 or whatever, wasn't it?
Yeah.
Oh, no, that was about 600, I think.
Before you taped the hole, it was like 606.
Yeah.
And it was 550, 560, I think, after.
Yeah, if I wasn't lazy, I'd move the lift over there and check above that door and see if it is actually open. I mean, you can see it from the outside, but it's good to have like something to chase, you know, chase it later.
Looking at the detail on the top of that one that we can get access to, if it's pulled back that much, that could be pretty significant. If it actually is getting behind that sheet metal and getting all in the house. So, yeah. Kind of in that same ballpark. I had a few things taped up over there. So.
Yeah.
But yeah, it's an option for, you know, people building really efficient homes.
Mm-hmm.
Yeah, that was 500 CFM, you know, 600 CFM. The fan goes up to 1500 CFM.
Okay, so I could have twice the leaky house and still use that.
Yeah.
So is it conceivable to say, like, a guy that is doing what we do, that wants to know this, it's as easy as hooking up with you guys and purchasing a system, and then you guys would help with some training, or you have some online stuff?
Yep, we got some online stuff, and it's a small enough industry that we we talk to a lot of people on the
Yeah.
phone.
You got guys like Randy around here who
got
love
Randy.
love sharing
Yeah,
information.
Yeah. So it's a pretty tight knit group of people too. So the people that get into it and figure it out, they seem happy to share it. So yeah, if they call us up, we'll absolutely help them figure it out.
Cool. Yeah, it's good to know. Yeah, that is a lot smaller to carry around.
Yeah.
Awesome.
And if you're ever doing duct work, you can kind of do double duty where you test your duct work and test your building with it if you're doing super tight work.
Would you just put an E on that sucker
We could.
to do duct work?
Pressures are different, but
Oh, okay.
this one works a lot. You certainly could try.
Okay.
This is a lot easier to set up.
Awesome.
And this is the hard part. So when you connect it to a piece of ductwork
Gotcha.
over a register or where it's a cabinet door,
Yeah.
that's a lot easier to connect than trying to find.
So do you have to cover every register when you do that?
Yeah.
Okay.
Yeah. So when we test a building, we close all the intentional exterior openings, doors, windows outside. Same concept with ductwork. The intentional openings are registers now. So you got to go and tape off. And just flicking a register closed, that's
not enough.
That's not a seal. You want to actually tape it off.
Okay.
So yeah, you tape those and then run the system. If you've got ERVs or HRVs that are tied in, there's setups where you'll tape those in, in and out of one of those systems. But other than that, it's pretty straightforward.
Okay. Interesting.
Cool, huh?
Yes, it is, man. I think it's just cool because, like I said before, I like the test. I like the challenge. I mean, that E is going to get used, man. I love it.
I can't
yeah,
wait.
that's.
I can't wait.
I mean, one way or the other, we're going to figure it out. We're going to chase every leak possible. So yeah, and that house is 1,800 square foot, so it's not huge. So that makes it harder, in a sense, if you're going off of volume,
Right.
but also not as many places to have holes.
Yep.
15 CFM.
15 CFM.
That little one is 15 CFM.
On his lowest test pressure, okay, this is possible.